Nature has a way of reminding us of its immense and sometimes terrifying power. On September 16, 2023, in a remote corner of eastern Greenland, one such reminder unfolded in spectacular fashion. It was a day like any other in the quiet, icy landscape of Dixon Fjord. But then, without warning, a huge section of a 3,000-foot cliff simply gave way. A colossal mass of rock and ice weighing millions of tons broke free and began its thunderous descent. This wasn't just a small rockfall, it was a catastrophic landslide, an entire piece of the mountain surrendering to gravity's pull and plunging into the cold, deep waters of the fjord below. It was a truly awesome display of geological force in action. The moment this enormous volume of material, over 25 million cubic yards of it, crashed into the fjord, it displaced a staggering amount of water. The energy from the impact had nowhere to go but outwards, creating a wave of almost unbelievable proportions. This was not an ordinary tsunami caused by an undersea earthquake. This was a mega tsunami, born from a landslide. The initial wave surged upwards, reaching a mind-boggling height of 650 feet. To put that into perspective, that's taller than a 50-story skyscraper. A wall of water of this magnitude is a rare and formidable event, capable of reshaping coastlines in an instant. This monstrous wave then began its journey down the narrow, 2-mile-long corridor of the fjord. It moved with incredible speed and force, a destructive pulse of energy traveling through the water. Fortunately, this part of Greenland is extremely remote and largely uninhabited, which prevented a human catastrophe. However, the wave did cause significant damage to an unoccupied research post located on Ella Island. The facility suffered around $200,000 in damages, a testament to the sheer power unleashed by the landslide. It serves as a stark reminder of the potential danger that exists in these seemingly peaceful frozen landscapes, where nature's quiet can be shattered in an instant. The event itself was a classic example of how interconnected Earth's systems are. The stability of the cliff was linked to the ice that held it together. The landslide was the trigger, and the water was the medium for the wave's destructive energy. This single event, happening in just a few moments, set off a chain reaction that would not only devastate the immediate area, but would also send puzzling signals across the entire planet. Scientists would soon discover that the story of the Dixon Fjord mega-tsunami was far from over. In many ways, it was just beginning, offering a unique chance to study a truly extraordinary natural phenomenon up close. What happened next was truly bizarre and turned this local disaster into a global scientific mystery. Long after the initial wave had crashed, seismic stations thousands of miles away began to pick up strange signals. From Alaska all the way to Antarctica, sensitive instruments detected unusual seismic waves rippling through the Earth. These were not the sharp, sudden jolts of an earthquake. Instead, they were slow, gentle, and incredibly persistent. For 9 whole days after the landslide, these mysterious waves continued, pulsing with a steady rhythm every 92 seconds. It was as if the fjord itself had a heartbeat that the entire world could feel, a phenomenon that left scientists completely baffled. This strange global signal prompted an enormous international investigation. The puzzle of the persistent waves brought together a huge team of over 70 researchers from 41 different institutions around the globe. Experts in geology, seismology, oceanography, and satellite imaging all collaborated to figure out what was going on. Led by scientists like Christian Svenevig from the Geological Survey of Denmark and Greenland, the team worked to piece together the evidence. The main question was, how could a single landslide in a remote fjord create such a long-lasting and rhythmic global signal? It was a scientific whodunit on a planetary scale. The answer, they discovered, lay in the unique shape of Dixon Fjord. After the initial mega-tsunami, the huge volume of water didn't just settle down. Instead, it began sloshing back and forth along the length of the fjord, like water in a giant bathtub. This rhythmic motion is known as a seiche. As the water sloshed, it acted like a massive piston, repeatedly pushing down on the seafloor. This constant rhythmic pressure on the Earth's crust is what generated the slow, pulsing seismic waves that were detected so far away. The fjord had effectively become a natural machine, converting the energy of the wave into a steady, 9-day-long global hum. Even with this explanation, the event was incredibly difficult for scientists to model accurately. When different research groups tried to create computer simulations of what happened, they got very different results. One group's model suggested the water surface in the Seiche rose and fell by about 8.5 feet with each pulse. Another group's model, using different assumptions about the fjord's underwater shape, estimated the movement was much larger, perhaps between 23 and 30 feet. This discrepancy showed just how complex these events are and how much more we need to learn about the hidden geography of our planet's most remote places. Solving this puzzle would have been nearly impossible just a few years earlier. The key to understanding the Dixon Fjord event came from a revolutionary piece of technology orbiting our planet. A brand new satellite mission called SWOT, which stands for Surface Water and Ocean Topography, happened to be in the right place at the right time. Launched in December 2022, SWOT was designed specifically to map Earth's water with unprecedented detail. Unlike older satellites that could only measure water levels at specific points, SWOT can scan a wide 30-mile swath of the surface, creating high-resolution maps that reveal every detail. This was a game-changer for science. The SWOT satellite provided scientists with a breakthrough. It gave them a clear picture of the water sloshing back and forth in the fjord, confirming the Seiche theory. For the first time, researchers could directly observe the effects of a mega tsunami in such a remote and inaccessible location. The fjord's steep, icy cliffs make it extremely difficult and dangerous to study from a boat, but the satellite gave them a safe, overhead view. This incredible data allowed researchers like Alice Gabriel from UC San Diego to see exactly how the water was behaving, providing the crucial evidence needed to connect the landslide to the strange global seismic signals. The event in Dixon Fjord highlighted a critical link to a much larger global issue, climate change. Scientists quickly pointed out that the warming of our planet played a significant role in making the landslide happen. For centuries, glacier ice acted like a natural glue, supporting the steep rock faces of the fjord. But as air and ocean temperatures rise, this supporting ice is melting and retreating. Without this icy buttress, the cliffs become far more unstable and prone to collapse. This process is making landslides and the mega tsunamis they can trigger much more common in the Arctic and other cold regions around the world. This wasn't an isolated incident. A similar tragic event occurred in 2017 in Karat Fjord, also in Greenland, where a landslide-triggered tsunami killed 4 people. These events are a clear warning sign that the risks in the Arctic are increasing. As the region becomes more accessible due to melting ice, human activity, including tourism and cruise ship traffic, is on the rise. More people are venturing into these beautiful but increasingly hazardous areas, often unaware of the hidden dangers lurking in the unstable cliffs above them. The Dixon Fjord event served as a powerful case study for understanding and preparing for these new risks. The 2023 mega tsunami has become a vital lesson for the scientific community, demonstrating both the growing dangers in the Arctic and our improving ability to study them. By combining the data from the SWOT satellite with the global seismic readings, scientists have developed a new and powerful way to monitor these remote regions. The event proved that it's possible to detect and analyze major landslide tsunamis almost as they happen, even in places with no people or instruments on the ground. This fusion of satellite and seismic data is now being considered for early warning systems to protect vulnerable coastal communities and ships. The detailed information gathered from the Dixon Fjord event is now being used to improve forecasting models. Scientists are digging back through historical seismic archives, looking for the faint, rhythmic signatures of past Seiche events that may have been missed. By finding and studying these hidden tsunamis from the past, they can build a better understanding of how often these events occur and which areas are most at risk. This historical perspective is crucial for predicting where the next big landslide might happen, allowing authorities to take preventative measures and potentially save lives in the future. Ultimately, the goal is to create a more robust system for safeguarding people in an increasingly unpredictable world. As the Arctic continues to warm and change, the risk of events like the Dixon Fjord mega tsunami will only grow. The insights gained from this one event are invaluable. They teach us about the complex physics of landslides, the behavior of waves in fjords, and the far-reaching effects these can have. This knowledge is not just for scientific curiosity. It is essential for practical safety, helping to inform decisions about land use, shipping routes, and emergency preparedness in polar regions. The giant wave of Dixon Fjord was a shocking display of nature's raw power, but it was also a gift to science. It provided a perfect, real-world laboratory for testing new technologies and theories. It has pushed scientists to think differently about how to monitor our planet's most remote corners and has highlighted the urgent need to understand the consequences of a warming climate. By learning the lessons written in the ice and rock of Greenland, we can hopefully become better prepared for the challenges that lie ahead, working to ensure that when the next mountain falls, we are ready for it.